The prevailing design philosophy in generative AI software right now is the absolute elimination of user friction. Information synthesis must be instantaneous. Tools like Google's Notebook LM and the underlying Gemini 1.5 Pro model both represent the absolute apex of this ideal. Using a mixture of experts architecture, these systems seamlessly ingest and map millions of tokens in seconds. The core assumption driving this development is straightforward. Faster, broader machine processing automatically translates to better human understanding. But if the machine performs 100% of the cognitive heavy lifting, we have to ask what actually happens to the learning process of the human operator. Researchers from Cambridge University and Microsoft put this exact frictionless design to an empirical test. They divided hundreds of students into distinct groups, having them study historical texts using either a large language model alone or through manual note-taking. While frictionless user experiences dominate software architecture, applying that same zero-friction standard to human learning relies on a deep biological misunderstanding of how the brain builds knowledge. In the Cambridge study, students relying solely on an LLM retained significantly less information than those taking manual notes. Yet feedback revealed a sharp paradox. Students overwhelmingly preferred the LLM, an assumption completely disconnected from their poor performance. This disconnect between perceived ease and actual retention is the illusion of fluency. A user reads a machine-generated summary and mistakenly conflates the text's clarity with their own internal comprehension. Cognitive science identifies the antidote to this illusion as desirable difficulty. The brain requires mental friction. The physical act of filtering, summarizing, and writing information is biologically necessary to form durable neural traces. Technical optimization strips away that friction. By removing the cognitive struggle required to synthesize data, the system actively degrades the user's ability to form long-term memories. To see how AI removes this friction, we look at the traditional mechanism for knowledge retrieval in large language models, vector database RAG. RAG relies on a chunk and retrieve operation, fracturing documents into disconnected fragments to find specific semantic similarities. This chunking method is highly effective for retrieving L1 explicit facts, simple, direct answers extracted from a single source. But traditional RAG breaks down at the L4 level, hidden rationales. Queries that require cross-document logic fail because the global context is lost in the chunking process. Gemini 1.5 Pro solves this L4 problem through long context source grounding. Instead of chunking data into fragments, the model ingests thousands of documents whole, preserving the structural and semantic integrity of the entire dataset. This is precisely what allows modern environments like Notebook LM to instantly identify undocumented logical contradictions across a massive 50-repository legacy codebase. Source grounding achieves massive scale reasoning, but by handing that finished rationale directly to a human, the architecture completely removes the cognitive friction required for the human to actually learn it. This visual maps the breakdown when L4 reasoning is instantly supplied. In cognition, lacking desirable difficulty forces cognitive offloading. In agency, AI overtrust reduces independent judgment. In emotion, users experience cognitive dissonance and guilt. In ethics, surveillance destroys the psychological safety required for intellectual risks. The Cambridge study demonstrates that the illusion of fluency impairs immediate retention, but as the Favero framework suggests, the long-term risk is an erosion of independent judgment. The user slowly loses the capacity to evaluate information without a machine intermediary. We return to Gemini 1.5 Pro and the reality of processing its massive 2 million token context window. When you query that much data, you experience computation lag, a physical delay as the machine's attention mechanism cross-references vast amounts of text. Human biology has its own equivalent, cognitive lag. This is the slow, deliberate process of reading, structuring arguments, and taking notes. The danger in modern software design is the expectation that the machine's computation lag should entirely replace the user's cognitive lag. Taking manual notes operates on a physical speed limit. That restriction forces the human brain to evaluate, compress, and organically filter the incoming information. Typing every word turns a user into a stenographer. Writing by hand, or actively summarizing, requires the actual translation of ideas into understanding. Computation lag is a machine feature. Cognitive lag is a human requirement. Substituting them breaks biological learning. The solution is not to abandon high-capacity tools like NotebookLM, but to reconstruct their integration into the user experience. We achieve this by building a content engine, utilizing the Gemini API as an automated preprocessor to format and structure messy raw data. Using AI to handle L1 and L2 explicit facts, clearing this administrative friction, is the correct and safe application of zero-friction design. The architectural danger zone exists strictly at the L3 and L4 synthesis levels, where critical thinking is required. For these advanced queries, we must intervene by inserting a scaffolding layer between the advanced LLM output and the end user. This layer acts as a Socratic filter. Instead of delivering a finished summary, it prompts the AI to ask targeted, complex questions back to the user. This UX design forces the human to perform the final L4 rationale synthesis themselves. It intentionally reintroduces desirable difficulty. NotebookLM's source grounding supports this workflow, keeping every piece of data anchored to a specific timestamp or document page so the user can verify and cite their manual conclusions. True architectural elegance requires knowing exactly when to deploy zero-friction automation for data processing and when to enforce productive cognitive struggle for the human mind. The way we manage long context models now dictates the future of educational technology, software development, and enterprise knowledge management. The user interfaces of tomorrow cannot be built as a race to generate the fastest, most frictionless summary. Artificial intelligence architectures must be purposefully designed to augment our human epistemic agency, rather than simply replace it. Developers and machine learning engineers carry a strict ethical responsibility to build systems that actively protect our biological capacity to reason. The standard metric of success for enterprise AI tools is shifting from total time saved to total knowledge retained. In a technological landscape where context windows are functionally limitless, the ultimate competitive advantage is no longer the capability of the machine, but the preservation of the human mind's ability to think critically.